So let's take a look at one of these. Let's take a look at that same vector EF. Let's write it up here as we have, so we have EF vector. I'll do it like that. It's another way to look at it, same thing. So we have vector EF. The tail, where it starts, is at 1, 5. The head is at 7, 4. Goes from 1, 5 to 7, 4. So now we have a direction. Notice that I drew a little right triangle. What is the rise? The rise is a -1. Why? Because we're going down 1. That's a negative direction. Okay, so we went down, we went -1. We went a y direction, negative y direction 1. What was our run? Our run was 6. We went a positive x direction of 6. Now, how do we find our magnitude? The magnitude, or the length of that vector, is simply the distance formula for that vector. Okay? We do that, that's simply the run squared plus the rise squared, the square root of all that. So what's the magnitude equal? Run squared plus the rise squared. What's the run? The run is 6 squared plus -1 squared. What is that when we do it? It's the square root of 36 plus 1. Magnitude equals the square root of 37, or the magnitude equals approximately 6.0828. Okay? Now, if we were to put it in component form, okay, if we were to put it and move this coordinate grid so that basically E, or the tail, is at the origin, it makes it pretty simple. Why? Because this is our run and this is our rise. So all we do is magnitude equals 6 squared plus -1 squared. Magnitude equals square root of 37 equals 6.0828. So all we do is take what would be considered in a line, it's just a slope. Okay? So that's all we're doing there is basically considering that we have it in component form. Oh, what's the difference between component form and standard form? It looks the same. Component form just says, oh, we know that this original vector really wasn't at origin. We moved the coordinate grid so it would start at the origin, the tail would be at the origin. And this is what it looks like if it were to start at the origin. So that's how we determine the magnitude part of this two-dimensional vector. The magnitude. Okay? We just use the distance formula, figure out what the length of the hypotenuse is, and that's our magnitude. Okay? Now let's look at how we might determine what the direction is.